Welcome to the webinar, Closing the Gap Between GIS and BIM with InfraWorks and Civil 3D 2020. I'm just going to give you a quick introduction of Microdesk, the host company. So Microdesk was founded in 1994 as an Autodesk reseller with a simple mission to assist architecture, engineering, construction, owners, and GIS firms with improving workflows and integrating project delivery technology. 25 years later, and that mission still holds true. Microdesk is a well-established AEC consulting firm with 13 offices in the US and UK, and we have over 250 AEC consultants, solution specialists, and software developers. Urbanization studies suggest that the U.S. will build 114 cities the size of Boston in the next 30 years. Microdesk can help to make sure you're prepared to meet these demands. We use software from industry leaders such as Autodesk and IBM, and combined with our vision and passion for sustainability, we meet the demands of urbanization. Our team of industry expert consultants are redefining project delivery and asset management. We offer a number of consulting services to help support the industry with the demands of urbanization. These services include building information modeling services, enterprise strategy and workflow assessments, technology management, mentoring and support, and application development. Now I'm going to pass on the webinar to our presenter, Karen, and she'll take it from here. Thank you, folks.
So just a little background information about me. I'm a solution specialist here at Microdesk. I have 12 years of experience in the industry, and I'm a professional engineer. And I'm also a certified AutoCAD Civil 3D professional and a certified AutoCAD Revit user. So I just wanted to go over the agenda for the webinar today. I just want to talk briefly about what GIS actually means, what it is, the history of the Esri and Autodesk partnership. I'm going to talk about Esri ArcGIS Online, which is a key component for the connector. Then we're going to discuss the connector for InfraWorks and Civil 3D. I'm going to talk about the shared reference point extension, which connects Civil 3D with Revit. And then I'm going to talk a little bit about sharing data between Esri, ArcGIS Pro, and Autodesk software. So what is GIS? So GIS is kind of a master category. Essentially, it refers to systems for connecting information with geographic locations. So that information is often in the form of geometric information, such as points, lines, polygons, and volumes, and tabular information, such as tables and databases. So when we combine tabular qualitative data with geometric data, it's very powerful. It allows us to do a lot of advanced analysis and spatial visualizations in space and time. So you might think of a traffic simulation, or maybe a visualization of ocean temperatures that changes across the color spectrum, and it changes in time. Those are some of the examples of the things we can do using GIS. One thing I want to mention is that GIS is a master category, so it doesn't just refer to ArcGIS. You could also describe Civil 3D and InfraWorks as GIS, because those are just systems for organizing geographic data with attribute data. The real power of GIS is coordinate systems. So what is a coordinate system? The one we're all familiar with is obviously latitude and longitude. We probably work a lot with state plane coordinates. Whenever you start to feel frustrated with sharing data between programs, just remember that we're just talking about XYZ points. So the most important thing is just to understand where you are in space. If you understand what coordinate system you're in and what your XYZ point is, you're going to have a lot less trouble sharing data between programs. So coordinates allow us to locate GIS data at an actual location on Earth, and we can see how various features relate to each other, be those buildings, roadways, airflows, or traffic. The most important thing to think about is before you even start working on a project, you want to start thinking about your coordinate system. What coordinate system are you designing in? And what is your location within that coordinate system, what's your survey benchmark? So if you just have a rough understanding of where you are, what the northing, easting, and elevation values of your project are, that's your XYZ values, you're going to have a lot less trouble sharing data between programs. Okay, I'm just going to talk a little bit about the history of the partnership between Esri and Autodesk. So in November 2017, Autodesk and Esri announced a new partnership. In January of 2018, a new version of ArcGIS for AutoCAD was released, and that basically covered versions 2015 through 2018. In July of 2018, Autodesk launched the connector for ArcGIS, which was integrated with InfraWorks. And then the connector was integrated with Civil 3D and Map 2020 in March 2019. So these are new features. There's still some known bugs. Some of them are still in the beta stages. So we want to start thinking about this. This is basically the future, but you might have a few frustrations along the way as this is a brand new application. I just wanted to share this quote with you, what the thought process behind all of this is. This is from Esri. The way project teams work today with GIS and BIM is often fragmented, disconnected, and manual. Esri and Autodesk are working together to provide an environment where GIS professionals and designers and engineers can collaborate across the project lifecycle by integrating GIS with BIM. So that's basically the vision of all of these applications. Okay, so here is a quick overview of the connector for ArcGIS. The connector works in conjunction with Esri ArcGIS Online, which is an online portal for exploring, sharing, and creating GIS content. The Autodesk Connector, it's a platform for pulling cloud-based GIS data into site models. So currently it's available for InfraWorks and Civil 3D. It's going to become a tool that can really share information across a lot of different softwares directly through the cloud. So I just want to talk quickly about Esri ArcGIS Online. You are going to need an account to work with the connector. So it's basically an online portal. That's all it is. On this portal, you can make maps. So you can build interactive online maps. You can add base maps. You can upload your own data. You can do some different dynamic data animations and visualizations. You can also share and collaborate, so you could have multiple people collaborating on a map together. You can invite other people to view your map. And there is some analysis tools directly through this portal. So determining optimum site placement, conducting route analysis, and analyzing some geospatial statistics and patterns. This is sort of what the home page looks like. You can see the different tabs at the top there. So the gallery is a location for sharing maps and scenes. The online map, this is where you can actually create your own GIS map directly online. You can add a lot of public data, a lot of base maps. You can also add files directly from your computer. So if you export a shape file from Civil 3D, you could add that directly to the map here. And you can also share this so other people can take a look at the map. Scene is essentially, it's very similar to map. It's just a native 3D platform. So again, you're going to be adding your own base maps, adding custom layers. You can configure content. You can take snapshots and share them. The content portal is somewhere where you can store different files, maps, layers, scenes, and tools. It's basically a storage location. The organization panel, this is where you can organize your organization. So for example, you could have your members and your permissions, the different licenses assigned to your organization, the amount of credit you have, the amount of storage you've used. That's all going to be covered there. And then settings, this is just some basic settings information. Let me go ahead and show you a screen capture of what this actually looks like. So you can see the different tabs there at the top. This is sort of what the gallery looks like. We have a bunch of different maps saved in our gallery here, different things we could save. I'll go ahead and click on the map. You can take a look at the map view. See, we've got a really nice mapping portal here. We can apply a bunch of different base maps here, imagery. You can zoom into your area of interest here. Try a different base map. You can also go ahead and add shapefiles directly from your computer here. You can save this. You can save this to your gallery. You can share it, print it. So that's my map. I'll go ahead and click on Scene. So here we've got a 3D model view of the world. I'm going to click on one of the Esri examples. You take a look at this. Imagine you're building a Revit model, how you could position this in the real world. You know, this is what the future is going to be like. We're going to have 3D models of every city, and we can kind of see the piping, see the relations of the buildings with each other in real time. So that's kind of what the scene looks like. I'm just going to orbit that so you can see you can orbit around in there as well. Okay, so that's an overview of ArcGIS Online. Now I'll talk a little bit about the connector. So in InfraWorks, you can find the connector button on the data source panel. And the spatial extents of your model in InfraWorks are determined automatically. So once you set up your InfraWorks model, those spatial extents will go right into the connector for you as the default. In Civil 3D, you're going to find that button. You're going to go to the Planning and Analysis workspace, and that's on the Home tab on the ribbon. You see that big button right there. In Civil 3D, you must delineate your area of interest. Okay, so the different content sources available are these. My content, that's your personal content, and that's associated with your personal Esri ArcGIS profile. My groups, so you can have different groups you might belong to, and they might share different data with each other. Organization, this might be your company, so this is the organization that everything is under. And then public data, there's a lot of data that's just available online that's open to the public, which is a really great resource. So you can also just grab public data. So in InfraWorks, what you're going to do is you're going to have your area of interest here. It's based on the extents of your model. And then you're just going to click on the little green button to accept that. So in Civil 3D, you're going to zoom to your area of interest. You have similar buttons. You can either draw a rectangle, draw a polygon, you can import a polygon. Typically, what you're probably going to do is zoom the model where you want your area of interest to be, and then just click on that little green square again. So then once you're there, you're going to click on the category of data you want to look at. You're going to select the group. You can see here we've got Concord Trail Map. So there's a bunch of layers combined in this. We can pick which parts of the layers we want to bring in. And then where it says select feature type, we're just telling it the InfraWorks feature type we want to be represented by this data. Once the data is imported, we can stylize it in InfraWorks. You can also modify it. You could edit it. I'm going to go ahead and show you a screen capture of this. Now, I just want to mention this is InfraWorks 2020.1. So it looks a little different. It might look a little different from what you're used to, but it's all the same buttons. So let's just go ahead and take a look at this. So I go ahead and click on data sources. Then you can see the connector button there. I'm just going to click on that. Just position the window so we can see it a little better here. Okay, so there's my area of interest. You can see that was determined based on my model. There's the button associated with that. We can also draw a rectangle. So now you can see this is my public data. I could also be pulling my own personal data there. So you can see all the different public data available. There's quite a lot of data available. I'm just going to type in a search term to simplify this a little bit. And then I'll select a data source, a publicly available one, just some street maps. I'm going to go ahead. You can see all the data that's in here. A lot of different layers. I'm going to go ahead and deselect most of these. I'm just going to bring in one of these. I'm just going to bring in driveways. So now what I'll do is I'll tell it it's a coverage area. You're probably familiar with that from InfraWorks. That's a typical area type. So now I click that add to my design. You can see that it's pulling that in. Sometimes it takes a little while. There it is. Okay, so you can see those driveways came in. There they are. Now you might need to configure this a little bit. In this case, it auto-configured, but just make sure that you are draping it. You can see the roll style for the stylizing of it. Just make sure you're draping that. And obviously you can change the way that looks if you want to anytime. Choose a different style. Now, let's say that we edited the data. We could export that back. We could use a save back option here. Now, this is going to give me a warning. There's no modification, so there's no reason to save it back. But you can just save that back to your content if you wanted to. You can also share the entire InfraWorks model. Here you can see I'm on the Present Share tab, Publish to ArcGIS. If we click on that, we're going to actually publish this entire model back to ArcGIS. So I'm just going to go ahead and connect. I'm going to tell it to use the entire model as the extent. You notice the coordinate system is UTM there. We'll tell it which feature types we want to grab. So here's my area of interest. Again, it was able to find that automatically. There's my object types, ArcGIS category that's going to be matched up, and then that's just the names it's going to use. So it doesn't like spaces in the names, so we're going to go ahead and take the spaces out. You can add some tags. It's going to my content. Publish. You can see this publish succeeded. You can go ahead and take a look at that right now if you want to view in ArcGIS. Okay, I'll just go ahead one. Okay, so once you get into ArcGIS, I'm going to my map. Here you can see that data was pulled right in. There it is. So that's kind of what that looks like. So you could obviously share, you could share it this way with anyone over the internet. You could share the entire InfraWorks model that way. Okay, in Civil 3D, I'm going to go through the process in Civil 3D now. Data imported into Civil 3D will come in as a map feature. And you're going to have all those shapefile attributes will be present as feature properties. So you might want to be in the planning and analysis tool space when you're working with this. Just something to be aware of. So in the map space pane, you can stylize the map feature. You could change the way it looks. You could look at the table. I'm going to go ahead and show you all of that. We'll go ahead and show you this screen capture video. Okay, so we want to be in the planning and analysis tool space. You can see the big Autodesk Connector for ArcGIS button there. Click on that. So we're going to get a similar window. Now in this case, I do have to zoom in. So I have to zoom in on my location. Find it. You can also import. If you have a shapefile, you could import it. In this case, I'm just going to zoom in. Okay, so this is kind of my area of interest here. So now I'm going to go ahead and click on this green button. You can see the other options there. Here's my area of interest. You can see similar tabs at the top here. We'll go ahead and choose public. Put in that Concord search term again. And then I'll scroll down. I'll find my street map that I want to bring in. This kind of sees data a little differently than InfraWorks. So I'm just going to go ahead and click Add. That data comes in. Now you can see that data came in. It's reading the metadata. Okay, you can see the line work. If I click on that in the properties, you'll notice that's a map feature. It's a feature type. So if we take a look at that in the map pane, we can open the table. We can take a look at the attribute data of those shapefiles. It's all in there. You can change the way this looks, edit the style. change this to a different color. And there is the data. So that's how you can pull data right down from the internet right into your Civil 3D models. Okay, so I'm going to demonstrate the publishing from Civil 3D to ArcGIS. Now, my current model is actually in Massachusetts State Plane. It's very common to be in State Plane. I just want to warn you that because this is a brand new software, Massachusetts State Plane actually doesn't publish to ArcGIS online. So you'll see we get, it kind of goes in the ocean when we publish it. So if you recall, the UTM published correctly. So you do need to just be aware of that when you're doing this. You can always geo-reference them at a later time, but unfortunately, not all of the Civil 3D coordinate systems are going to publish directly to ArcGIS Online right now. So in order to publish this, what you want to do is you want to go back into the Civil 3D workspace, and you'll find that button right on the Output tab of the ribbon. And you're going to go right into a very similar dialog that we saw before. When you go to export the data, you're going to see something very similar to export to land XML. So you're really exporting Civil 3D objects, alignments, pipe networks, sites, things like that. Again, you're going to be assigning the metadata. And then once you've exported this data, it's going to show up in your contents in your ArcGIS Online. Go ahead and show you this. And you can also project that into Scene or in Maps once you've got that data in there. Okay, so let me just go through the workflow really quick here. So again, we're going to change the workspace back to Civil 3D. And if I go to the Output tab on the ribbon here, you see that button there, Publish to ArcGIS. I'll go ahead and click on that. Here, I'm going to be taken through a very similar, here's the export pane. This looks a lot like the land XML. You can also pick from the drawings. You can see the Civil 3D objects, pick from drawing. So here you can see it doesn't define the area of interest correctly. If you read the help files, it gives you the full list of the coordinate systems that work. I just want you to be aware of that. So here's the object types, alignment, pipe structures. You can see the ArcGIS category they're coming in under, line, point, and that's the name they're going to be applied to. So again, we don't want any spaces. We're going to get rid of those. And you can't use the same name. That's why I got another error. I can't have the same name twice. Okay, that's going into my content. So I'll go ahead and publish that. It takes a little while. So you can see that was published directly to ArcGIS. I can say View in ArcGIS. I'll just go to my skip forward. Okay, so once you're click through that, once you get logged in, it will take you into your map. And here we're out in the ocean just because there was an issue with the coordinate system. You could always geo-reference that, but I just wanted you to be aware that that's still an issue that's out there that they're working on. Okay, I'm going to talk a little bit about the Autodesk Shared Reference Point extension for Civil 3D and Revit. So anyone who's ever had to transfer data back and forth between Civil 3D and Revit, you know what a headache it is. This is an extension that's going to help you with that a little bit. You can download this directly from your Autodesk account. You can see what they're called there if you're looking for it. And just install those and you should see those appear. So in Civil 3D, the tool will appear under the tool box in the tool space tab. The way this works is you identify 2 points that are in common between the Civil 3D and the Revit model. You click on those 2 points in Civil 3D, and then you import that into the Revit model. And then it's able to essentially align them. The only thing I just want you to be aware of is the 2 points have to be at the same elevation. So they can have an elevation, but they have to be at the same elevation, at least for now. Okay, so this is kind of what it looks like. You can see you select 2 points, you set your units, you save an XML file, and then in Revit, you're basically going to import that XML file. And then you're going to identify the same points in Revit, the same 2 points. Then you click on the Location tab in Revit. You tell it we're using that shared reference point. And you're going to tell it to use true north in the site properties, in the view properties. And if you do all that, then you will be good to go. You can export Revit models as DWGs, and they'll go right into Civil 3D in the right location. So let me go ahead and show you that. And then to export the Revit to Civil 3D, just make sure that you set the units and coordinates. Just tell it to use foot and tell it to use the shared coordinate system. And the exported Revit model will now come in directly as an XREF directly into your model. Let me go ahead and demonstrate this. Okay, so I'm going to click on my tool space. You can see my tabs. I go to the toolbox. So now that is showing up there, export shared reference point for Revit. So it says select origin point. This can be any 2 points. I'm just going to show you the error really quick. See this error? Selected point has a different elevation to the origin. So the points have to be at the same elevation. So I'm just going to do that again without. So it's like that point, that point. I'll just remember those points when I do it in Revit. Change my units to feet. So now I've got an XML file. I'm just going to save this somewhere. Now I just go into Revit. Here I'm in Revit. I'm going to go into a 2D view. Okay, so now I go to my add-ins, import shared coordinates. And now I need to remember what those 2 points were. I'm just going to take the same 2 points. So that point. And this point. Now I'm just going to select that XML file I created. Okay, so now I just have to tell it I want to use that. So basically what I do is I go to the Manage tab. And I'm going to go to the Location button here. Now you pick Site. And you're just to tell it we're using the shared reference point, make current. Okay, so it doesn't update, but if you scroll down here in the properties, you're just going to change the orientation to true north. Okay, now we're in the correct coordinate system. So now if I were to go ahead and export this DWG now, just make sure you go in and check that the units and the coordinates are set to foot, because that's my unit, and make sure that your coordinate system is set to shared right there. Say OK. And I just go ahead and save that DWG. I'm just going to do one more thing. I'm going to save a 3D view, so I'll click on the 3D view. I'm going to go ahead and export this to DWG format. Now I just want to make sure my units and my coordinates are foot and shared. Then I'll just say OK. Just save that DWG. Okay, so now if I go back into my Civil 3D model, give that a second to save. I'm going to go ahead and bring those in as XREFs. So I'll grab the 2D version first. And you notice we want to set the insertion point to 0, 0, 0 because we're in real coordinate systems now. That comes in an exact right location based on those 2 points that we told it. Now you can also do this with the 3D version. So I'll go ahead and do that. Here's my 3D view. 0, 0, 0 is your insertion point. So there's your 3D model, and you can actually take a look at it in 3D. Zoom in there, you can see the nice 3D model. So that's a way that you can simplify your life with the shared coordinates. Now, I do want to mention anyone who's familiar with the project site point, and the survey site point in Revit, we're actually modifying those points. So this is just a tool that helps you modify those points correctly. So it's just something I want to mention if anyone has used those tools before. Okay, I do want to talk a little bit about Revit models and InfraWorks. So when you're importing a 3D model into InfraWorks, large coordinate system positions can distort geometry. So it's better to save your Revit model closer to the origin of 0, 0, and then offset the location in InfraWorks. Again, if you understand where you are in space, if you understand what the coordinate value of the corner of your building is, it's not that difficult to just numerically set it up in InfraWorks. So just be aware, if you just know, if you're just able to maybe take from Civil 3D the coordinate value of the corner of your building, you can just enter that into InfraWorks and position it correctly. If you want to read more about the geometry issue, I have a link here you can take a look at about 3D models and InfraWorks. I'll go ahead and show you how you can position a Revit model in InfraWorks. So if we go ahead and click here, we're going to go ahead and bring in a Revit model. Just uploading that. This takes a little time. I've trimmed it down using editing. So here we have not configured, so you're going to want to configure that. So you can see here, it's kind of in a dummy coordinate system. So we're going to use interactive placing to position it. You could also change the rotation manually there. I'll just go ahead and click in interactive placing. So you can see here, I can just literally place this where it should go. And it's going to correct the Z elevation, so it's sort of projected at ground surface. Just double click. It's actually right on your cursor. You just double click. So you can see that's assigned the latitude and longitude value. It's going to go ahead and process. Now you can see that is in there. See what it looks like. I also just wanted to point out that you can actually, if you knew the corner of your building and you set that to 0 in the Revit model, you could manually type in the values and the rotation, and then you could position it more exactly. So that's kind of how you would position that in Revit and InfraWorks. Apologies. Okay, I just want to briefly talk about sharing data between Esri and Autodesk. So Civil 3D can import common GIS file formats. So that might be shape, BEM, TIFF, and Esri can import common CAD formats. So there are tools to help you exchange data back and forth between Civil 3D and Esri. Esri ArcGIS Scene can import the Revit format, so you can bring Revit buildings directly into 3D GIS modeling spaces. And InfraWorks and Esri ArcMap, they're basically built on a common GIS platform. So they're looking at the same file formats. So shapefile, DEM, TIFF, they're actually working on the same data types. So it's you can easily share data between InfraWorks and ArcMap. And you can also export 3D Esri shapefiles as 3D DWG files. This is a little bit computationally intensive, but you can do it if you needed to. All right, I'm going to go ahead and show you how you can bring DWGs. Right now we're in ArcGIS Pro, so this is the desktop software for Esri. Let's go ahead and take a look at this. So all you need to do is you just need to attach your folder. So I'm just going to say add folder connection. I'm just going to put in where my DWGs are saved. You can see there they are. Now these DWGs are georeferenced correctly. So I can just bring them directly in. It's that easy to bring the DWG in. So the map and the DWG are both in Massachusetts State Plain. You can see that they come in, they speak very natively to each other. Each DWG layer comes in on a separate level like that, a separate Esri layer. So it can get really messy if you have a really complicated drawing. Here I'm doing a 3D version of this. This was a 3D DWG. Processing, it just takes a little while. I put all of this geometry on the same layer just for simplicity's sake, but if you wanted to have different color for the roof, different color for the walls, you could just put that information on different layers in your DWG, and then you'll be able to control it in Esri the way that A wall and S grid are shown there. So you can see that just comes right in because it was georeferenced. It knows where to put it. In terms of the elevation, it's using an option called on ground. So it's essentially just projecting this building on the ground. It's still processing there. There, it just came in. So there you can see that building right there in Esri scene. Now, maybe you have a situation where your map and your DWG aren't in the exact same coordinate system, so it's a little bit more complicated. There is a tool for that, which I'm going to show you. So I'm going to go to my tools here, Analysis tab, Tools. Click on the tools. You can see I have it already pulled up, CAD to GeoDatabase. So if I use this tool, I can tell it my CAD drawing, my DWG drawing. It's going into the project GeoDatabase. And what I can do here is I can actually tell it the spatial reference I want to use. So I can actually just, if there's any confusion, I can tell it the exact spatial reference to use. Come down here, select Massachusetts State Plane. And we're not assigning a Z right now, we're just projecting to the ground. So then we just say run. And this again will bring this in. And this also works for 3D drawings. And you can, in 3D drawings, you can also use the actual value. If you have assigned actual elevations, you can use those values when you're projecting in ArcGIS. And that's going to appear now in the project GeoDatabase. So that's that tool. Now let's talk about exporting. So if I want to export this, I have another tool here called Export to CAD. If you want to find these tools, you can just search in your tools. If you put in CAD, you'll see all your CAD tools. So now we're going to export Esri data to CAD. So you just pick whatever feature you want to export. In this case, I'll just pick one of these polyline features. You tell it your DWG version, your output file, and then you can just say run. It just takes a minute. I'll show you what this looks like in CAD. So there, it actually projects it into the map as well, but it also creates that DWG file. And this is what it looks like. So it's very easy to export this GIS data directly to CAD file formats, and the coordinate system will carry over, or at least the coordinate system values. Okay, now we're going to talk about how you get Revit drawings added. So I'm going to go ahead and add the Revit folder. You can see I'm in a 3D scene view here. So again, we can just drag these in, and it's actually set up to read the native file format. So here's my drawing. If I expand this, you'll see all the different types of data are, you can drag only one. So you can just bring in the walls if you didn't want all the data. I'm just going to bring in the architecture, so I'm not bringing in structural or anything like that. So here's my my Revit model. Now again, this Revit model was georeferenced, so you can see it's coming in the exact right location. You can also georeference these from within the program itself if you needed to. You just use the georeferencing tools if they're not positioned correctly already. You see how that all looks nice. And all the colors of the different Revit objects, you can control all of those. If you expand the Revit model, you can see all the different data types are here. So if we wanted to change the way any of this looks, we can also take a look at the attribute table. This again, this is just the Revit attributes. So you can go ahead and take a look at those Revit attributes. And again, you don't have to bring in the whole thing. You can just bring in a little bit of it. I'm just showing you the walls attribute table. This is right from Revit. Okay, let's talk about how you can publish back to ArcGIS or the web ArcGIS Online. You can do that right from this program, ArcGIS Pro. So we'll go ahead and take a look at that. Once you have your model, you have a bunch of different options for sharing this online. So you can create a project package. This contains everything, and it's almost like a e-transmit package in Civil 3D. You can share that to the ArcGIS Online, a map package, a mobile map. This would be for like an iPad. You could take a look at it right in the mobile. So this is just a web map. You can actually share this on any website. So it doesn't even have to be Esri Online. It could be any website. You could share a map. And you can even share tools. So if you wanted to have an analysis tool right on your website, you could share that there as well. Okay, so that concludes the presentation. So if anyone has any questions you want to ask, you can go ahead and ask. Okay, some people are pointing out that the portal didn't launch until September. I might have been looking at the beta, so I might have had the dates slightly wrong. It's possible that I had those dates slightly wrong. Let me see what other questions we have. Okay, in Civil 3D 2021, features come in as Civil 3D objects. Okay, so I might have been using the older version there. Are versions of models stored in ArcGIS, are they overwritten? So you have to give unique names every time you publish the ArcGIS Online. So you won't have an issue of versions being overwritten because you're actually not allowed to use the same name for the project. If using free Esri Online, we are unable to bring DWGs into ArcGIS. What benefits do you gain using the desktop version over online when coordinating Civil 3D files? So the desktop version of ArcGIS Pro, it actually is a much more powerful program. So there's actually many, many more tools that are available. Is there a way to have text transfer between AutoCAD and GIS? Yes. So annotation does transfer between CAD and GIS. It might not look great, but it does transfer, so you can always format it once you get it over. Is ArcGIS Online free? I think there is a free version, but to access most of the tools, I believe you need the paid version. So if anyone else has additional questions, are using BIM for InfraWorks, BIM 360 for InfraWorks. I'm not using BIM 360 for InfraWorks in this presentation, but we do have webinars on that topic. Okay, if there's no other questions, we can go ahead and close this webinar. Thank you all for attending.